These language models we've got access to now are, well, seriously mind-blowing in their potential.
Yeah, they really are.
But just like any powerful tool, the real magic comes from how you use them. And in the world of LLMs, that how boils down to one crucial skill: prompt engineering. Think of it as crafting the perfect key to unlock their capabilities. And what's really cool is you don't need to be some data science guru to do it. Anyone can learn to write effective prompts.
That's really the core of what we're digging into today,
Yeah.
prompt engineering. We've got a really insightful document here that lays out, what it is, why it's so incredibly important, gives you the practical know-how to get great results.
Exactly. Our mission today is to really get down to the nitty-gritty of writing killer prompts. We're not just scratching the surface with basic questions. We're exploring the subtle art of using different prompting tricks and understanding how even the LLM's internal settings can be tweaked to get surprisingly powerful outcomes.
Right. So by the end of our chat today, you should have a much more hands-on, much more detailed understanding of prompt engineering. You'll be ready to move beyond those simple back and forths and start using, more clever techniques to really harness the power of these language models.
Okay, so let's get right into it. What exactly is prompt engineering?
Okay. So simply put, a prompt is the text you feed in.
Just text. Or other things, too.
Well, sometimes images, other media too, yeah. It's the input you give to a large language model to get, a specific result back.
Right.
But, and this is the key part, crafting effective prompts. Well, it's a bit more involved than just typing a question. It's influenced by quite a few things, actually.
Like what? Give us the quick rundown.
Well, first off, the specific language model you're using makes a difference. Whether it's Gemini or a GPT model, Claude, or even open source options like Gemma or Llama. Oh. Then you've got the data the model was trained on, the various configuration settings that come with the model, and even your own choices like the words you use, your writing style, the tone you take, how you structure your prompt.
Right. Okay.
And the overall context you provide. It all plays a part.
So it's not just a case of asking nicely and hoping for the best answer, then?
Not at all. Prompt engineering is really a process of trial and error. It's about designing and refining high-quality prompts, through experimentation.
Experimentation.
Yeah, to really guide these LLM towards producing the most accurate and relevant results. The ultimate aim is to set the LLM up to predict the sequence of words or tokens that perfectly matches what you're looking for.
And as we know, these LLMs are basically prediction machines, right? They're constantly trying to figure out the next word based on all the text they've learned from.
Precisely. So a well-crafted prompt is really about leveraging those predictive abilities. And the sheer range of tasks you can accomplish with good prompts is quite impressive.
Like what kind of tasks?
Oh, all sorts. We're talking about things like summarizing long pieces of text, pulling out specific bits of information, answering all sorts of questions, sorting text into different categories.
Classification, yeah.
Right. Translating languages, both human languages and computer code, writing new code from scratch, creating documentation for code, and even tackling complex reasoning problems.
Wow. It's like unlocking a whole toolkit of abilities just by being smart about how you phrase your requests. And you mentioned picking the right model. Is it a one-size-fits-all situation for prompts, or do they need to be adjusted?
That's a great question. Prompts often do need to be fine-tuned for the specific model you're using. What works brilliantly with, say, Gemini might need a little tweaking to get the best out of a Llama model, for example.
Okay.
So, yeah, thinking about which model is best suited for your task is a key first step in the prompt engineering process.
Okay, so we've got the prompt itself, but it sounds like there's more to getting good results. You mentioned model configurations. What exactly are we talking about there?
Yes, exactly. Beyond the text of the prompt, most LLMs offer various configuration options that give you control over the output they generate. Setting these correctly is a really important aspect of effective prompt engineering.
All right, let's dive into these configurations then. What's the first thing we should understand?
One important setting is the output length. This basically lets you control the maximum number of tokens.
Tokens, right, like chunks of words?
Yeah, chunks of words or parts of words that the LLM will generate in its response.
And why would we want to mess with that? Seems simple enough.
Well, generating more tokens requires more processing power from the LLM. And this can lead to higher energy use, potentially slower response times, and, depending on the platform you're using, it could also mean higher costs.
Makes sense. So if I tell it to have a shorter output length, will it automatically give me a more to-the-point answer?
Not exactly, no. Reducing the output length simply tells the LLM to stop generating tokens once it hits that limit. It doesn't necessarily make the output itself more concise or better written. If you need a short answer, you'll likely also need to word your prompt in a way that encourages brevity.
Got it. So it's more of a hard cap than a request for conciseness. Are there any specific situations where strictly limiting the output length is really useful?
Yes. It's particularly relevant for some of the more advanced prompting techniques we'll talk about later, like React.
Okay.
In those cases, you might want to prevent the LLM from just rambling on with potentially irrelevant information after it's achieved the desired outcome.
Okay, that's output length sorted. What's the next dial we can play with in the configuration toolbox?
Next up are the sampling controls. Now, as we discussed, LLMs predict probabilities for what the next token should be.
Right, the likelihood of the next word.
Exactly. And then one of those possibilities is chosen or sampled to become the next part of the generated text. The key settings that influence this selection process are temperature, top K, and top P.
Temperature sounds interesting. What does that actually do?
So, temperature controls the randomness in how the next token is selected. If you set a low temperature, the model tends to stick to the most predictable options, giving you more deterministic responses.
Okay, so more factual, maybe.
Generally, yeah. This is good when you want factual or very focused answers. On the other hand, a higher temperature introduces more randomness, leading to more diverse and sometimes surprising results.
So a low temperature is for when you want a straight, reliable answer, and a higher temperature is for when you're exploring more creative or unexpected possibilities, like brainstorming.
That's a good way to think about it, yeah. A temperature of 0 is the most predictable. It's called greedy decoding, where the model always picks the single most likely next token.
Always the top choice.
Always the top choice. As you increase the temperature, it makes other, less probable tokens more likely to be chosen. If the temperature gets very high, all the words in the model's vocabulary become almost equally likely to be picked.
And you mentioned that Gemini's temperature control is similar to something called the softmax function. What's the connection there?
Yeah, the document makes that connection. Think of the softmax function like a spotlight. A low temperature in Gemini, just like a low temperature in softmax, focuses that spotlight very tightly on the single most probable next word.
Yeah.
A higher Gemini temperature, like a wider softmax temperature, widens the beam to include other, less likely but potentially more creative options around that most probable word, allowing for more variation.
Okay, I think I'm getting a handle on temperature. Now, what about top K and top P? They also sound like they control which tokens get picked.
They do, yes. Both top K and top P, which is also known as nucleus sampling, are ways to limit the selection of the next token to only those that the model thinks are the most likely. This helps to manage the randomness and diversity of the generated text as well.
So how are they different from each other if they both limit the choices?
Good question. Top K sampling is pretty straightforward. It looks at the list of all the possible next tokens and their probabilities, and it only considers the top K most likely ones.
K being a number you set.
Exactly. For example, if you set K to 30, it will only consider the 30 most probable next words. If you set a high K, you're giving the model more choices, which can lead to more creative output. A lower K makes the output more focused and factual. And a top K of 1 is essentially the same as that greedy decoding we talked about with temperature 0.
Got it. Top K is about picking from a fixed number of top choices. What about top P then?
Top P works a bit differently. Instead of a fixed number, it looks at the probabilities of all the next tokens and starts adding them up, starting from the most likely one.
Adding up probabilities.
Yes, it keeps adding tokens to the potential pool until their cumulative probability reaches a certain value, P, which you set. This value P ranges from 0 to 1.
Okay.
So P of 0 is, again, greedy decoding, just the top one. While P of 1 means basically all possible tokens in the LLM's vocabulary are considered.
So top P is more about the total probability mass of the selected options rather than a fixed count.
Exactly right. It dynamically adjusts how many tokens it considers based on how probable they are. The document actually recommends experimenting with both top K and top P, and even using them together sometimes to see what gives you the best results for what you're trying to do.
So how do all these settings actually work together? It seems like they could get a bit complicated, influencing each other.
They certainly can interact. The document explains that in a platform like Vertex Studio, if you have temperature, top K, and top P all enabled, the process goes something like this. First, the model identifies all the tokens that meet both the top K condition being in the top K most likely and the top P condition, their cumulative probability doesn't exceed P.
So it's like an A and D gate. Both conditions must be met.
Precisely. Then the temperature setting is applied to randomly select from this smaller, filtered set of candidate tokens.
Okay, so K and P act as initial filters to narrow down the options, and then temperature adds the element of chance within that filtered group. What if you only have one of K or P available? Maybe the platform doesn't offer both.
Good point. If only top K or top E is an option, then the model just uses that single setting to filter the tokens before making the final selection based on temperature, or randomly if temperature isn't available.
And what if temperature isn't available as a setting at all?
If you can't control the temperature, then after the tokens are filtered based on whatever top K and or top P settings you have, the next predicted token is simply chosen at random from that remaining set of possibilities.
Makes sense. The more controls you have, the more precisely you can probably shape the output. The document also mentions what happens if you push these values to the extreme.
Right.
What are some of the effects of those extreme settings?
Yeah, that's interesting. At the very extreme ends, one setting can indeed become the dominant factor and make the others almost irrelevant.
How so?
For example, if you set the temperature to 0, as we said, it becomes completely predictable, greedy decoding. And the top K and top P settings essentially don't matter because the model will always pick that single most probable token. On the flip side, if you set the temperature incredibly high, it becomes the main driver of the output, and the tokens that made it through the K and P filters are then just randomly picked anyway.
What about really low or really high top K values?
Well, if you set top K to 1, then temperature and top P don't really matter because only that single most probable token meets the criteria.
Back to greedy again?
Essentially, yes. Yeah. If you set top K to a very high number, maybe the size of the LLM's entire vocabulary, then almost every token with any chance of being next will be included in the top K list. So it doesn't really do much filtering at all.
And the same kind of thing happens with top P at the extremes, P0 or P1.
Exactly. If you set top P to 0 or a very tiny value, most systems will only consider the single most probable token, again making temperature and top K irrelevant. If you set top P to 1, then all tokens with any non-zero probability will meet the criteria, so it also doesn't act as much of a filter.
These are really helpful nuances to understand. So, with all these options, temperature, K, P, where should someone even begin when trying to configure these settings? It feels like a lot to juggle.
It can be. The document provides some good starting points as general guidelines, which is helpful.
Okay, like what?
For relatively coherent results that still have a touch of creativity, it suggests a temperature around 0.2, maybe a top P of 0.95, and a top K of 30.
A balanced start.
Yeah. If you're aiming for more creative and varied outputs, you might push the temperature up to, say, 0.9, top P maybe 0.99, and top K around 40.
More open-ended.
Right. For less creative, more focused responses, maybe try a lower temperature like 0.1, top P 0.9, top K 20.
More constrained.
Exactly. And if your task always has a single, clearly correct answer, like solving a math problem we discussed, the beginning with a temperature 0 is generally recommended.
That's some great practical advice. It's important to remember, though, as the document points out, that with more freedom in these settings, higher temperatures, top K and top P, the LLM might also generate text that's less relevant to what you initially asked for. A bit more randomness can lead it astray sometimes.
Absolutely. It's a balancing act. You're balancing allowing for creativity against maintaining coherence and relevance, and the ideal settings will really depend on the specific thing you're trying to achieve. There's no single right answer.
Okay, so we've got a solid understanding of what prompt engineering is and how we can tweak the LLM's output using these configuration settings. Now let's get to the real strategies, the different prompting techniques we can use. Where should we kick things off with those?
Right, the techniques. The document emphasizes that while LLMs are trained on massive amounts of text data and are generally pretty good at following instructions.
Yeah, they seem to understand a lot.
They do. But the clearer and more well-designed your prompt is, the better the LLM will be at predicting the kind of text you're looking for. And there's some specific techniques that really leverage how these models learn and work to get you those relevant results.
Sounds good. What's the first technique we should take a look at?
The most fundamental is probably general prompting, which is often referred to as zero-shot prompting.
Zero shot. Okay, what's the idea behind that name?
A zero-shot prompt is the simplest kind. You basically just describe the task you want the LLM to do, along with maybe some starting text to get it going.
Like a question or instruction.
Exactly. Could be a question, the beginning of a story, or a set of instructions. The zero examples part means you don't give the model any examples of the kind of output you're expecting. You just ask.
Can you give us a clear example of a zero-shot prompt in action?
Sure. The document has a good one for classifying movie reviews. The goal is to take a movie review and categorize it as positive, neutral, or negative. So the prompt looks something like this. Classify movie reviews as positive, neutral, or negative. Review. Her is a disturbing study revealing the direction humanity is headed if AI is allowed to keep evolving unchecked. I wish there were more movies like this masterpiece. Sentiment. And then you just leave it blank after sentiment for the model to fill in.
Interesting. So just by stating what you want it to do and giving it the review, the model is expected to understand and provide the classification. The document also mentions the specific model settings they used for this example, right?
Yes, it does. For that particular zero-shot example, they used the Gemini Pro model. They set a low temperature of 0.1, a token limit of just 5 for the output, because they only expect one word back, really.
Positive, negative, or neutral.
Exactly. And the default top K and top P settings, which in this case essentially mean they aren't actively filtering the result much beyond the temperature. The document also points out that words like disturbing and masterpiece in the review could make the model's prediction a little more nuanced or tricky.
Right, conflicting signals there. And what if just telling it what to do in a zero-shot prompt doesn't quite get you the results you need? What's the next thing to try?
Good question. If zero-shot prompting isn't giving you what you're looking for, you can try techniques that involve giving the model some demonstrations or examples within the prompt itself.
Showing it what you mean.
Exactly. This leads us to one-shot and few-shot prompting.
Okay, so we're going from 0 examples to 1 and then to a small number. How do these work?
Well, the main idea with one-shot and few-shot prompting is that by showing the model examples of what you want, you help it understand your request better, and you can guide it towards a specific output format or style.
Makes sense.
So a one-shot prompt includes a single example. You show one input you might provide and the corresponding output you'd expect. The idea is that the model can then learn from this one example and try to do the same for a new, similar input you give it next.
And few shot is just doing the same thing, but giving it more examples to learn from, like 2 or 3.
Exactly. A few-shot prompt provides several examples to the model, showcasing the pattern you want it to follow. It's similar to one-shot, but by giving it multiple examples that demonstrate the desired pattern, you increase the chances that the model will correctly follow that pattern for new, unseen inputters.
How many examples are we usually talking about when we say few shot? Is there a magic number?
No magic number, unfortunately. The number of examples can vary quite a bit depending on how complex the task is, how good your examples are, and what the specific LLM you're using is capable of. However, the document suggests a general guideline of using maybe 3 to 5 examples for few-shot prompting.
Okay, 3 to 5 is a starting point.
Yeah. For really tricky tasks, you might need more, and you might need fewer if you're limited by how much text you can actually fit into the context window limit.
Right, that limit is important. The document has a few-shot example for taking pizza orders and turning them into a specific computer-readable format called JSON. Can you walk us through that one?
Sure thing. The goal here is to take a customer's pizza order, described in everyday language, and parse it into a valid JSON format.
Useful for an ordering system.
Very. The prompt starts with the instruction, parse a customer's pizza order into valid JSON. Then it gives examples. The first example shows an input like, I want a small pizza with cheese, tomato sauce, and pepperoni, followed by the JSON response in the correct JSON structure.
Showing the format clearly.
Exactly. The prompt then gives another example of a slightly different order, maybe a medium with different toppings. And then the final instruction, now I would like a large pizza, the first half cheese and mozzarella, and the other tomato sauce, ham, and pineapple. JSON response. Leaving it for the model to figure out the JSON for that more complex half-and-half pizza order based on the pattern it saw.
That's a great way to show the model exactly the structure you're looking for, especially for something structured like JSON. And the model settings used here were similar to the zero-shot example, but they allowed for a longer potential response, right?
Yes. Same Gemini Pro model, low temperature, top KP effectively disabled, but with a token limit bumped up to 250 to allow for the more complex JSON output.
Makes sense.
And the document really emphasizes that when you're picking examples for your prompts, they should be relevant to the task, show a variety of different inputs and outputs, be high quality, and be clearly written.
Garbage in, garbage out applies to examples too.
Absolutely.
Yeah.
Even small mistakes in your examples can confuse the model. It also mentions that if you want the model to handle a wide range of inputs, including unusual cases, maybe someone orders something weird, it's a good idea to include examples of those edge cases in your prompt to make it more robust.
So good examples are absolutely key to getting the most out of one-shot and few-shot prompting. What's the next set of techniques we should look at? Seems like we're building up complexity here.
We are. Next, we have system, contextual, and role prompting. These are all techniques used to guide the LLM's text generation, but they each focus on slightly different aspects of how you set up the prompt.
Okay, let's break them down one by one. What is system prompting all about?
System prompting is really about setting the overall context and purpose for the language model, for the entire interaction, or a significant part of it. Think of it as defining the big picture of what you want the model to do.
Like its overall job description.
Yeah, exactly.
Yeah.
Defining its fundamental capabilities or purpose for this task, like specifying that it should act as a translator between French and English, or that its primary goal is to classify text into predefined categories.
So it's like giving the model a high-level instruction about its main job for this interaction.
Precisely. The document gives an example where they're still working on classifying movie reviews. Remember that?
Yeah, positive and negative neutral.
Right. But the system prompt adds extra requirements for how the output should look. In one case, it tells the model that it should only return the sentiment label in uppercase letters. Simple formatting rule.
Oh, okay.
In another case, it tells the model that it needs to return the output in a specific JSON format, following a defined structure or schema.
And using that JSON format for the output has some specific advantages, doesn't it? You mentioned structure before.
Yes, the document points out several benefits of getting your data back as JSON objects, especially when you're using a prompt to extract information.
Like what?
Well, in real-world applications, you don't have to manually structure the data yourself. The model can return data in an organized way, which is particularly useful for things like dates, times, lists. More importantly, by asking for a specific JSON format, you're kind of forcing the model to stick to that defined structure.
Right, constraining it.
Which can really help to reduce hallucinations or the model just making stuff up or adding irrelevant information in its response. System prompts can also be really useful for setting boundaries on the model's behavior, sort of like guardrails.
How so?
For example, by adding a line like, "You should be respectful and avoid generating any harmful content," setting that overall tone and safety expectation.
That's really powerful, setting those overarching rules and expectations with a system prompt. Now, what about role prompting? How's that different?
Role prompting is where you explicitly tell the language model to adopt a specific character or identity, a persona.
Like method acting for AI.
Kind of. It helps the model generate responses that are consistent with that assigned role, including the kind of knowledge, tone, and behaviors you'd expect from someone in that role.
So you're basically telling the model to pretend to be a certain type of person or entity.
Precisely. The document gives examples like telling the model to act as, say, a seasoned book editor, or a really friendly kindergarten teacher, or maybe a highly enthusiastic motivational speaker.
I can see how that would change the output dramatically.
Absolutely. Once you've given it a role, you can then give it prompts that are relevant to that role. For example, you could prompt a model acting as a teacher to create a simple lesson plan. The document shows an example where the model takes on the role of a travel guide.
Okay.
And provides 3 suggestions for museums to visit in Amsterdam. Then another example where it adopts a more humorous and inspirational style to give travel tips for someone visiting Manhattan.
That sounds like it could really influence not just the information provided, but also the entire tone and style of the response. The document even lists some effective styles you could ask the model to use, like being confrontational or descriptive, formal, humorous, and so on.
Yes, exactly. By defining a role, you're giving the AI model a kind of template for the tone, style, and focused expertise you're looking for, which can significantly improve how relevant and useful the output is for your specific needs.
Okay, we've covered system and role prompting. What's the third in this group? Contextual prompting.
Contextual prompting involves giving the model specific details or background information that is relevant just to the particular conversation or task you're working on right now. It helps the model understand the specific situation and tailor its response more effectively.
So it's about giving the model the immediate background it needs for the specific question or request, rather than an overall role or system behavior. Exactly. It's more dynamic and task-specific. The document gives an example where they set the context by saying, "You are writing for a blog about retro 80s arcade video games."
Nice.
Then, the prompt asks the model to suggest 3 topics for blog articles, along with a short description of each. By providing this context right at the beginning of that request, The model is much more likely to come up with suggestions that are relevant and fit the theme of that specific blog.
It's like setting the stage for the model right before you ask it to perform. I can definitely see how that would lead to more focused and useful responses, especially compared to just asking for 3 blog topics.
For sure.
It's interesting how these 3 system, role, and contextual, while having their own main purposes, could sometimes overlap in practice, couldn't they?
You're absolutely right. There can be a fair bit of overlap. For instance, you might have a system prompt that assigns a role to the model. You are a helpful travel agent, and also includes specific contextual details for the current task. The user wants budget-friendly options for a weekend in Paris.
However, understanding the primary goal in each technique system for the big picture purpose, role for the voice and style, contextual for the immediate task and details, helps you design your prompts with clearer intention and analyze how each type of information influences the model's output. It helps organize your thinking about the prompt.
Okay, we've covered a lot of ground with these fundamental prompting techniques. What's the next trick in our prompt engineering toolkit? Where do we go from here?
Okay, next up we have a technique called step-back prompting. This is a really interesting way to try and get better performance on complex questions or creative tasks.
Step back.
Yeah.
What's the core idea there? Sounds counterintuitive almost.
Well, the technique involves first prompting the LLM to think about a more general question or concept that's related to the specific problem you're ultimately trying to solve. Then, you take the answer it gives to that general question, and you use that answer as part of the context in the subsequent prompt where you ask for the answer to your original, more specific problem. It's like taking a step back to consider the broader principles or context before diving into the specific details.
That's a clever idea. How does that actually help the model give a better answer to the specific question in the end?
The theory is that by first considering the more general underlying principles or related concepts, the LLM can access and activate relevant background knowledge and reasoning skills before it tries to tackle the specific question.
Priming the pump, so to speak.
Exactly. It can lead to more accurate and insightful responses in the end. Step-back prompting kind of encourages the LLM to think more broadly and apply its knowledge in potentially more creative ways. Essentially, it helps to enrich the final prompt with more relevant knowledge that the LLM already has stored within its parameters.
Does the step-back technique help with any particular challenges, like maybe reducing biases in the model's responses? Is that mentioned?
The document suggests that it can potentially help to mitigate biases in LLM responses.
How?
By focusing on those more general principles first, rather than getting immediately bogged down in specific details or examples where biases might be more likely to surface or be reinforced.
Interesting. Can you give us a practical example of how step-back prompting works?
Sure. The document compares a regular prompt for writing a video game level storyline with using a step-back approach. The regular prompt simply asks the model to write a 1-paragraph storyline for a new level of a first-person shooter video game that is challenging and engaging.
Pretty standard request.
Yeah, and the output they got was okay, but the document notes it was somewhat generic, didn't really stand out.
Right, a very general prompt might just get a very general answer. So what's the step-back approach in this case? How do they improve it?
The step-back prompt first asks something different. Based on popular first-person shooter action games, what are 5 fictional key settings that contribute to a challenging and engaging level storyline in a first-person shooter video game?
Ah, so it asks for common successful themes first.
Exactly. This prompts the model to think about common and effective themes and environments in that genre of games. The answer it provided was a list of settings like, an abandoned military base, a cyberpunk city, an alien spaceship, that kind of thing.
Okay, so the model generates some relevant themes that are common in those types of games. What happens next? How is that used?
Then the original prompt about the storyline is rephrased, but this time it includes the answer from the step-back prompt as context. It says something like, context. Here, it lists the 5 themes the model just generated. Now take one of these themes and write a 1-paragraph storyline for a new level of a first-person shooter video game that is challenging and engaging.
I see. So you feed its own ideas back to it as inspiration.
Precisely. By giving the model these pre-generated themes as context and inspiration, the resulting storyline is much more specific and engaging. The example they give in the document is based on an underwater research facility theme, and it's much more detailed and vivid than the response to the original broader prompt was.
That's a really smart way to guide the model's creative process by first getting it to think about the foundational elements of a good storyline in that genre. It definitely sounds like it can lead to more focused and interesting results. What's the next technique on our list?
Okay, next we have chain of thought Contextual prompting. This is another really powerful technique, and it's particularly useful for improving the reasoning abilities of LLMs, especially on problems that need multiple steps.
Chain of thought. That sounds like it's about getting the model to show its work step by step, like in math class.
That's exactly the idea. Contextual prompting works by prompting the LLM to generate the intermediate reasoning steps as part of its response. It doesn't just jump to the answer.
Ah, okay.
This helps it to arrive at more accurate answers, especially for complex tasks that require some logical thinking or calculation before you can get to the final answer. It's often very effective, especially when you combine it with giving the model a few examples, few-shot Contextual in your prompt.
What are some of the main advantages of using this chain of thought approach? Why bother with the intermediate steps?
There are several key benefits. First off, it's quite... You usually don't need to do any special fine-tuning of the model just for this.
That's good. Accessible.
Very. It also makes the model's reasoning process more transparent. You can actually see the steps it took to arrive at its answer, which can be really helpful for understanding how it got there and for identifying if or where there were any logical errors along the way.
So it's interpretable. Helps with debugging the logic.
Exactly. Plus, the document mentions it seems to make prompts more reliable, more robust, across different versions of LLMs as they get updated.
That sounds really valuable for understanding and even debugging the model's thought process. Are there any downsides to using chain of thought? Any trade-offs?
The main drawback is pretty straightforward. Including all those intermediate reasoning steps in the response means the model generates more output tokens overall.
Ah, longer response.
Yeah, which can lead to higher costs depending on how you're paying for the API calls and potentially longer processing times to get the full answer back.
That makes sense. More output naturally means more computation. Can you give us a clear example of how chain of thought prompting works? Maybe that math problem?
Yes, the document provides a simple math word problem. When I was 3 years old, my partner was 3 times my age. Now I am 20 years old. How old is my partner?
Okay, a classic age puzzle.
Right. And a direct prompt, just asking the question without chain of thought, apparently gives a wrong answer of 63 years old in the example.
Oops, definitely not right. 3 times 20 plus 3. Nope. So how does adding chain of thought help in this case?
Well, by simply adding a phrase like, let's think step by step to the prompt, you encourage the model to break down the problem and show its reasoning.
Just that little phrase.
Often, yes. The Contextual response shown in the document then correctly calculates the partner's age when the person was 3, which is 3 equals 9. Then it determines the age difference, 9, 3 equals 6 years, and then it correctly adds that constant age difference to the person's current age. 20 plus 6 equals 26.
Much better, 26.
Right. So the step-by-step reasoning leads to the correct answer.
Wow, that simple addition to the prompt makes a huge difference. It's almost like you're explicitly asking the model to explain its logic to you as it goes. The document also mentions something called zero-shot set key. Is that just adding that let's think step-by-step phrase or similar to any prompt?
Yes, that's essentially what zero-shot set key is. You're triggering the reasoning behavior without providing explicit examples of reasoning steps. And as the document points out, chain of thought can become even more powerful when you combine it with giving the model one or a few examples in your prompt that demonstrate the kind of step-by-step reasoning you're looking for.
The few-shot version again?
Exactly. They show an example of single-shot SUCT with a similar age-related problem, where the first question and answer pair in the prompt demonstrates the desired reasoning pattern, and then the model follows that same pattern for the new problem you give it.
So the examples teach the model how to reason step by step for that specific kind of problem. That's really insightful. Are there particular types of tasks where chain of thought is especially useful? Where should you think about using it?
Yes, it's highlighted as being particularly useful for tasks like code generation.
Code generation. How?
Well, you can prompt the model to break down a complex coding request into smaller, more manageable steps before it starts writing the actual code. Like, first, define the variables, second, create the loop, etc.
Planning before coding. Good practice.
Right. It's also proving to be helpful for creating synthetic data by guiding the model through the logical assumptions it should make. Generally, the advice is, any task that you yourself might solve by thinking through the steps out loud is a good candidate for trying chain of thought prompting.
That's a great rule of thumb. If you would naturally explain your reasoning step by step, try prompting the LLM to do the same. What's the next technique we should explore? This is getting fascinating.
Okay, next we have self-consistency. This technique actually builds upon the idea of chain of thought to try and address some of the inherent limitations in the reasoning abilities, even of very large language models. Sometimes Cootie still makes mistakes.
Self-consistency. How does that work? How does it improve on chain of thought?
Well, while chain of thought helps with getting the model to reason, it often relies on a single, most likely path of reasoning, especially if the temperature's low. Self-consistency aims to improve reliability by combining two things: a sampling approach using a higher temperature setting.
Higher temperature means more randomness. Right.
Exactly. To generate multiple different reasoning paths for the same prompt. So you run the Coty prompt several times with temperature 0.
Okay, get different attempts at reasoning.
Yes. Then it looks at all the final answers that come from these different reasoning paths and selects the answer that appears most consistently across them through a kind of majority vote.
So it's like getting multiple different opinions or workings from the model on how to solve a problem and then going with the answer that comes up most often. Crowdsourcing the answer from the model itself.
That's a really good way to put it. It gives you a kind of pseudo-probability or confidence score in the correctness of the answer based on how many paths agreed. But the trade-off is pretty obvious.
More computation again.
Definitely. It has potentially high costs because you're generating multiple full responses, often including reasoning steps, for each single prompt you want an answer to.
Can you walk us through the actual steps involved in using this self-consistency technique?
Sure. First, you take your chain of thought prompt, maybe 0 shot or few shot. You send it to the LLM multiple times, say 5 or 10 times. Each time, you use a slightly higher temperature setting, maybe 0.5 or 0.7, to encourage the model to explore different reasoning paths and potentially arrive at different intermediate steps, maybe even different final answers.
Okay. Generate diversity.
Second, from each of the generated responses, you need a way to parse out and extract just the final answer to the original question, ignoring the reasoning steps for this part.
Got it. Just the final conclusion.
Third, you simply count how many times each different final answer appears across all the responses you generated. Then you choose the answer that is the most frequent, the consensus answer.
The document gives an example of using self-consistency for classifying emails, right? How did that work?
Yes. The task is to classify an email as either important or not important. They use a 0-shot chain of thought prompt, classify the email, let's think step by step, and send it to the Gemini Pro model multiple times. The example email they use has a friendly tone, uses some specific word choices, and even includes a bit of sarcasm.
Things that could trick an LLM.
Exactly. Things that could potentially mislead the LLM if it just took one path. Table 14 in the document shows the results of 3 different attempts. In some attempts, the model reasons that the email is important because it mentions a potential security bug. In another attempt, maybe it focuses on the casual tone and reasons that it's not important because of the lack of urgent language.
So different reasoning leads to different conclusions sometimes.
Yes. By generating multiple such reasoning paths and then looking at the final classifications, they found that important was the most frequent answer across the attempts shown, suggesting it's the most self-consistent classification, even if one path led to not important.
So even if some of the individual reasoning paths take a wrong turn, the overall consensus can still point to the correct answer. That sounds like a much more robust way to improve the accuracy of reasoning, albeit more expensive. What's the next technique we should learn about?
Okay, next we have Tree of Thoughts, TT. This is a technique that takes the core idea of chain of thought and generalizes it even further to handle more complex problems that might require exploration.
Tree of thoughts. That sounds even more involved than just a linear chain of reasoning like branches.
It definitely is more sophisticated. While chain of thought typically follows a single linear sequence of reasoning steps, Tree of Thoughts allows the LLM to explore multiple different reasoning paths simultaneously, like exploring branches of a tree. The document even includes a visual representation of this in Figure 1, contrasting the linear chain with the branching tree structure.
So the model can explore different potential solutions or lines of thinking, and maybe even backtrack if a particular path doesn't seem to be leading anywhere useful, like exploring a maze.
Exactly. 2T maintains a kind of tree structure where each thought is an intermediate piece of language, a coherent sequence of text that represents a step towards solving the problem. The model can then evaluate different nodes or thoughts in the tree and decide to branch out from the most promising ones to explore various reasoning directions further.
Wow.
This allows for a much more flexible and potentially in-depth problem-solving process, especially for tasks where there isn't just one obvious path forward. The document mentions that there's a more detailed explanation of this technique available in a separate notebook if people want to dive deeper.
That sounds really powerful for tackling tasks that require a lot of exploration and maybe some trial and error in the reasoning, like planning or creative writing maybe. What comes after tree of thoughts in our exploration?
After Tutti, we have React, which is short for reason and act. This is a really interesting paradigm that enables LLMs to solve complex tasks by not only using natural language reasoning, but also by interacting with external tools.
Reason and act. So the model can not only think through a problem internally, but also take actual steps out in the world, metaphorically speaking, to find more information or manipulate things.
Precisely. React allows the LLM to perform actions like conducting searches on the web using a search engine, or running code in a code interpreter, or maybe querying a database. It's essentially taking concrete steps to gather more information or interact with its environment, much like a human would when trying to solve a complicated problem that requires looking things up.
It sounds like a big leap.
It is. The document even notes that this is seen as an important step towards building more advanced AI agents that can actually do things, not just generate text.
How does this thought-action loop actually work in practice? What's the cycle?
React operates by continually cycling through a process of thinking, acting, and observing. It's a loop. First, the LLM reasons about the current problem and its state, and comes up with a plan for what it needs to do next. Thought. Then, based on that plan, it performs an action, for instance, using a search tool with a specific query act. After performing the action, it observes the result. What did the search return? Observation. Using what it has observed, the LLM then updates its reasoning, revises its plan if necessary, thought again, and repeats the process of thinking, acting, and observing until it finally arrives at a solution to the initial problem.
That sounds incredibly dynamic and much more like how a human would approach a complex task involving research. The document mentions that you really need to see some code to understand how it works. Can you give us a general idea without diving into code?
Sure. The document provides Python code snippets using a framework called LangChain, along with Vertex AI and a package for Google search results. The specific task they give to the LLM in the example is to find out the total number of children that all the current members of the band Metallica have.
A non-trivial lookup task.
Exactly.
Yeah.
Code snippet 2 in the document shows the kind of output you might see in a terminal as it runs. You can see that React initiates a sequence of thoughts and actions.
Like what?
First, it thinks, I need to find the current members of Metallica. Then it acts. Search. Current members of Metallica. It observes the search results, which lists the 4 members. Then it thinks, okay, now I need to find the number of children for each member. It then loops through. Act. Search. James Hetfield number of children. Observe the result, for example, 3 children. Act. Search Lars Ulrich number of children. Observe the result, for example, 3 children. And so on for Kirk Hammett and Robert Trujillo.
It breaks it down and uses the tool repeatedly.
Yes. Finally, it thinks, I have the counts for all 4 members, now I need to sum them up. And then it provides the final answer based on adding those numbers together.
So it's actively using a search engine to gather the specific, up-to-date information it needs to answer the question, rather than just relying on the potentially outdated knowledge it already has within its training data. That's a significant step up in capability.
It sounds like setting up React prompts would be a bit more involved, though, compared to the others.
It definitely requires more setup, yes. You need to make sure you're continually feeding back into the model its previous thoughts and the results of its actions so it maintains context. And you also need to provide it with good examples and clear instructions on how to use the external tools you want it to have access to, what format the actions should take, how to interpret the observations. The document mentions that there's a more comprehensive example notebook available on GitHub if you want to really dig into the implementation details.
Okay, React seems like a really cutting-edge technique for getting LLMs to tackle more complex real-world problems that need external information. What's the next technique on our list? Are we getting close to the end of the list? We're getting there. Next, we have Automatic Prompt Engineering, APE. This is a really fascinating concept. It's about using a language model itself to automatically generate new and potentially better prompts for a specific task.
A prompt to write prompts. That sounds very meta. How does that actually work? Using AI to improve AI interaction.
That's the idea. The basic process is you give a language model, let's call it the prompt generator model, a prompt that asks it to generate multiple different candidate prompts for a particular task you have in mind. You describe the task, maybe give an example prompt, and ask it to create variations.
Okay, so it generates a list of possible prompts. Then what?
Then you need a way to evaluate how good these generated prompts are. This is the tricky part. You might test them out on your target task with another LLM, the task solver model, and see how well they perform using some metric.
Like accuracy or relevance.
Exactly. Or you might use automatic metrics common in natural language processing, like BLEU or Rouge scores, if you have some reference outputs. You then select the best performing prompts based on your evaluation. You might even refine them further yourself, or even feed the best ones back into the prompt generator model to iterate and try to discover even better prompts. The ultimate goal is to find prompts that might even be more effective than ones that a human could easily come up with through manual trial and error.
Can you give us a practical example of how you might use this automatic prompt engineering?
Sure. The document provides an example of trying to train a chatbot for a t-shirt web shop. The goal is to make the chatbot better understand the various ways customers might phrase an order for a specific item, like one Metallica t-shirt size S.
Okay, handle variations in phrasing.
Right, so the first step in APD here is to write a prompt for a language model, in this case Gemini Pro, that asks it to generate different ways of saying the same thing while keeping the core, meaning the item, size, quantity, intact. Table 15 in the document shows 10 such example phrasings that the model generated, like, I need a small Metallica tee, get me one S-size Metallica shirt, etc.
So the model comes up with a bunch of different ways a customer might ask for the same item. What happens after that? How do you know which phrasing works best as a prompt for the chatbot?
That's the next crucial step. Evaluation. You take these generated phrasings, which are essentially potential prompts or inputs for your chatbot, and you evaluate how well the chatbot understands each one and correctly processes the order from it. You might measure success rate, or see if it extracts the item size and quantity correctly.
I see. Test them against the actual system.
Yes. You could also use those automatic metrics like BLEU or OJ, if you have a set of ideal ways you want the chatbot to interpret the order. Finally, you would select the instruction candidate, the phrasing that performs the best according to your chosen evaluation method. You could then decide to perhaps train your chatbot specifically on these effective phrasings, or use the best one as a canonical example in the chatbot's internal prompting. You might even tweak the best performing one slightly and evaluate it again to see if you can make it even better.
That's a really clever way to leverage the language model's own understanding of language variation to optimize how we interact with another system. It could potentially uncover more effective ways of phrasing things than a human might naturally think of. After APE, the document moves on to code prompting. This is specifically about using prompts to interact with and generate computer code, right? We touched on this a bit with React.
Yes, that's correct. This section focuses specifically on code. While Gemini's main focus is on understanding and generating text, this naturally includes text that represents computer code. The document highlights using the Vertex AI Studio environment as a good place to experiment with these kinds of code-related prompts, because it often has features tailored for code.
What are some of the main things you can do by using effective code prompting? What are the use cases?
The document covers several key applications. First, and perhaps most obviously, you can use prompts for writing new code.
Like asking it to generate a function.
Exactly. Gemini and other similar models can be very helpful in generating code snippets or even whole scripts in a wide variety of programming languages, which can significantly speed up the software development process. The specific example given in the document is a prompt asking for a bash script.
What does the script do?
It's supposed to automatically rename all the files within a given folder by adding the prefix draft to the beginning of each file name. Pretty common task. The actual bash code that the model generated in response to this prompt is shown in Table 16.
And I assume there's a warning label attached.
Absolutely. The document wisely recommends always carefully reading through and testing any code that is generated by an LLM before you actually rely on it for any real work. Don't just copy, paste, and run.
That's absolutely crucial advice. Always review and test code generated by an LLM. What else can you do with code prompting besides generating new code?
You can also use prompts very effectively for understanding and explaining existing code. This is huge.
How so?
Well, if you're working on a software development team, or maybe if you've inherited someone else's code base that's poorly documented, LLMs can be a really valuable tool for quickly grasping what a particular piece of code is doing. Table 17 in the document shows an example where the same bash script for renaming files, but this time without any of the comments that explain what it does, is given to the model with a simple prompt. Explain to me the below bash code.
And what does it output?
The output shown is a detailed, step-by-step explanation of what each part of the bash script does. Checks for the directory, loops through files, constructs a new name, performs the rename.
That would be incredibly useful for quickly getting up to speed on unfamiliar code, or for helping less experienced developers understand more complex logic. What's next in the code prompting toolkit?
Another really powerful application is using LLMs for translating code between different programming languages.
Like Bash to Python.
Exactly like that. Table 18 provides an example where the same bash script for renaming files is given to the model with the prompt to translate it into a Python code snippet. The generated Python code is also shown in the table.
That's useful.
It is. The document also includes a practical tip specifically for working with Python code in Vertex AI Language Studio. Apparently, you need to click the Markdown button to make sure the Python code is displayed with the correct indentation, which is obviously critical in Python.
Good tip. Code translation could potentially save a huge amount of time and effort when you need to move code between different systems or when you're working with different technology stacks. Finally, the document discusses using prompts for debugging and reviewing existing code. This sounds like it could be a real game changer for software developers trying to find and fix errors or just improve quality.
It definitely can be a big help. The example they provide shows a slightly modified version of that Python script that now contains a common programming error using to uppercase instead of the correct upper method in Python.
A JavaScript habit, maybe?
Could be. They also show the traceback error message that you would get if you tried to run this broken code in snippet 4. Then, in Table 19, the prompt asks the LLM to identify what's wrong with the code and to explain how to improve it.
And the result?
The output from the model correctly identifies the to uppercase error, suggests using upper instead, and even provides an improved version of the Python code.
Just fixes the bug.
It does more. The improved code also includes fixes for handling file extensions better, dealing with potential spaces in file names, using f-strings for cleaner string formatting in Python, and adding some basic error handling with the try except block.
That's fantastic. Not only does it pinpoint the immediate bug, but it also gives you constructive suggestions for making the code more robust and easier to maintain. The document does mention that the full response was cut off due to token limits in their example.
Yeah, sometimes the explanations can get long.
But the value of the suggestions it did provide is really clear. Finally, there's a brief mention at the end of the section about multimodal prompting. What's the key idea behind that, just quickly?
Sure. Multimodal prompting is essentially about moving beyond just using text as the input to guide LLMs. It involves using a combination of different types of input, different modalities, such as text combined with images or audio or video, and even code, depending on what the specific language model is capable of understanding and the kind of task you're trying to accomplish. It's a whole other exciting and rapidly evolving area within the broader field of prompt engineering.
Okay, wow. We've covered a really impressive range of prompting techniques, from the very basic zero shot all the way up to things like React and automatic prompt engineering. Now, to tie everything together, the document also provides a comprehensive section on best practices for writing effective prompts. What are some of the most important takeaways here? What should people really keep in mind?
Right, the best practices. The document really emphasizes up front that finding the absolute best prompt often involves some degree of experimentation. It's iterative.
No silver bullet.
No silver bullet. And using a platform like Vertex AI Language Studio can be incredibly helpful for this testing and refinement process. Now, one of the most crucial best practices, maybe the top one, is to provide examples whenever possible.
One shot, few shot.
Exactly. Especially using one-shot or few-shot prompting. As we've seen throughout our discussion, this acts as a really powerful way to teach the model what kind of output you're looking for, format, style, tone, and it can significantly boost the accuracy and relevance of the results.
Yes, giving examples seems to be a recurring theme for getting much better results from these models. It really anchors the model's understanding. What's another key best practice that we should keep in mind?
Design your prompts with simplicity and clarity in mind. Your prompt should be as concise, clear, and easy to understand as possible.
For you or for the model?
Both. For you when you're writing and maintaining them, and for the language model when it's trying to interpret them. Avoid using overly complex language, jargon if possible, or including unnecessary information that might just confuse things. The document provides a helpful before and after example of rewriting a travel-related query to illustrate this point, making it much clearer. They also suggest using strong action verbs in your prompts like summarize, classify, translate, generate to clearly define what you want the model to actually do.
Simplicity often seems to be the key, especially when you're communicating with a machine, even a sophisticated one. What else should we be aiming for when we craft our prompts?
Along similar lines, be as specific as you can about the kind of output you want. While very brief instructions can sometimes feel easier to write, they can also be too general, too ambiguous, and lead to less useful or unpredictable results. Providing specific details, either through system prompts that set overall expectations, or through contextual prompts that give the model relevant background for this request, really helps the model to focus on what's important and ultimately improves the accuracy and relevance of its response. The document gives some good do and do not examples related to generating a blog post about video game consoles. To highlight this, be specific about the aspects you want covered.
So being precise and giving enough detail seems crucial for effectively guiding the model. What about the use of constraints versus giving direct instructions? Is one better than the other?
That's an interesting point the document raises. It advises that it's generally better to use instructions rather than just constraints when you're writing prompts.
What's the difference then?
Instructions tell the model what you want it to do or produce. Write a summary in 3 bullet points. Constraints tell it what not to do or avoid. Do not mention the price. Avoid using technical jargon.
Okay. Why favor instructions?
Research suggests that positive instructions are often more effective because they clearly communicate the desired outcome. Constraints, while sometimes necessary, especially for things like safety or enforcing strict formatting, can sometimes limit the model's creativity too much, or even create conflicting guidance if you're not careful. The recommendation is to prioritize giving clear, positive instructions about what you do want, and only use constraints when they are really necessary for specific boundaries.
That's an interesting perspective, focusing on the positive goal rather than just the negative restrictions. What other practical tips does the document offer for day-to-day prompting?
Okay, a few more practical ones. Definitely control the maximum length of the response that the model generates. We talked about the max token setting earlier.
Right, the output length config.
You can usually set that in the model's configuration, or you can sometimes explicitly request a certain length within your prompt itself. For example, by saying something like, summarize this in a tweet length message or in under 100 words.
Okay. What else?
Also, it's often a good idea to use variables within your prompts to make them more reusable and flexible, like placeholders.
How does that work?
You can use placeholders, often denoted with curly braces like city or maybe topic, for information that might change each time you use the prompt. The document shows an example prompt about a city using a city variable, filled in with Amsterdam in Table 20. This is particularly useful if you're planning to integrate prompts into a software application where the inputs will change dynamically.
Using variables definitely makes prompts more adaptable and maintainable in code. What about experimenting with different ways of saying the same thing? Does phrasing matter that much?
Absolutely. The advice is to experiment with different input formats and writing styles. You might be surprised at how different language models, different configuration settings, like temperature, or even just slightly different word choices or prompt structures, can lead to noticeable variations in the output quality and relevance.
So try framing it as a question versus a statement.
Exactly. Try asking a question. What were the key features of the Sega Dreamcast? Making a statement. Describe the key features of the Sega Dreamcast. Or giving a direct instruction. List the key features of the Sega Dreamcast for the same underlying goal, to see which approach works best for that specific model and task.
It sounds like there's a fair amount of room for creative exploration and just trying things out in the process of prompt engineering. Are there any specific tips for when you're using few-shot prompting for classification tasks? Something to watch out for?
Yes, there's a good tip for that. When you're using few-shot prompting for tasks where you want the model to classify things into different categories like positive, neutral, negative, it's a good practice to mix up the classes in your examples.
Don't put all the positive examples first.
Right. The order of your examples usually doesn't matter too much for general tasks, but for classification, mixing the different response categories you're expecting, even if it's that positive, neutral, negative, can help the model learn the key distinguishing characteristics of each class more effectively, rather than just potentially overfitting to the order or frequency in the examples. The document suggests starting with around 6 examples total, maybe 2 of each for 3 classes, for testing purposes.
That's a subtle but important point to help avoid the model just learning a superficial pattern from the example order. What about keeping up with the language models themselves? They seem to change all the time.
That's crucial. It's really important to adapt your prompting strategies to model updates. Stay informed as much as possible about any changes in the underlying model architecture or any new capabilities that are introduced with new versions, like Gemini 1.0 versus 1.5.
So what should you do when a new model drops?
When newer versions of models come out, it's a good idea to test your existing prompts and see if they still perform as expected. Sometimes performance can change. And also, try adjusting your prompts to see if you can take advantage of any new features or improved capabilities that the newer model offers. Tools like Vertex AI Studio, which often support model versioning, can be very helpful for managing different versions of your prompts as the underlying models evolve.
So prompt engineering is definitely an ongoing process that needs to evolve along with the technology itself. What about the format of the output that we ask for? Any best practices there?
Yes, experiment with requesting different output formats, especially for tasks that aren't purely creative writing. Think about extraction, classification, summarization tasks. Try asking for structured formats like JSON or XML.
We touched on JSON earlier with system prompts.
Right. And the best practices reiterate the benefits. Getting your output in JSON format can make it much easier to automatically parse and use the information in downstream applications. It enforces structure, and as mentioned, it can potentially limit the occurrence of irrelevant or hallucinated content because the model has to stick to the schema you provide.
Structured output definitely makes it easier to work with the results programmatically. Do you have any advice on collaborating with others when it comes to prompt engineering? Should you do it alone or in teams?
The document suggests that if you're working in a team or just trying to figure out the best prompt for a particular problem, it can be really valuable to experiment together with other prompt engineers.
Why?
Well, getting different perspectives is always useful. Seeing how performance varies across different attempts, even when everyone's trying to follow the same best practices, can lead to some really insightful discoveries. Different people might naturally phrase things differently or think of different edge cases to include in examples.
That makes a lot of sense. Different people might naturally approach the same problem with slightly different phrasing and perspectives, leading to better prompts overall. The document also has some specific best practices just for using chain of thought prompting. What are the key things to remember there?
Okay, yes, a few specific COTI tips. First, it's generally recommended to structure your COTI prompts or examples, so the final answer comes at the very end, after the model has laid out its reasoning steps. Apparently, the process of generating the reasoning itself helps the model arrive at a better final answer.
Let it finish thinking before concluding.
Kind of, yeah. Also, if you're using COTI or especially self-consistency where you generate multiple reasoning paths, you need to make sure that you have a reliable way to easily extract just the final answer from the potentially long and complex text that includes all the intermediate reasoning. You need to parse it out.
Right, programmatically find the answer bit.
Exactly. And importantly, as we touched on before, when you're using chain of thought for tasks where there's likely one logically correct answer, it's often a good idea to set the temperature to 0. Since you're aiming for a logical step-by-step derivation, you want the model to be as deterministic and focused as possible in its reasoning process, not getting creative with the logic.
Deterministic reasoning makes sense for chain of thought. Finally, one of the most strongly emphasized best practices in the document, maybe the most operational one, is the importance of documentation. Why is that so crucial in prompt engineering? It feels like extra work.
It might feel like extra work, but documenting your various prompt attempts in thorough detail is absolutely critical for learning what works, what doesn't, and why over the long run. It saves work later.
Why is it so vital?
Because the output you get from language models can vary significantly depending on the specific model you're using, the configuration settings you choose, temp, k, p length, and even different versions of the same model over time. You might even see slight variations in the output from identical prompts run at different times due to the inherent randomness if the temperature isn't 0. Without documentation, you're just shooting in the dark each time.
So what should you track?
The document recommends using a spreadsheet or a similar system. They show an example template in Table 21 to keep track of key information. Things like a name or ID for the prompt, maybe its version, what the goal of the prompt was, the specific model used, all the configuration settings, temp tokens, KP, the complete text of the prompt itself, the exact output you received, a judgment on whether it was okay, un-okay, and any feedback or observations you have about why it worked or didn't.
That's quite detailed.
It helps. If you're using a platform like Vertex AI Studio, make sure you save your prompts there and maybe link to them in your documentation spreadsheet. If you're doing retrieval augmented generation, RAG, you should also track the specific query you used and maybe the settings for your data chunks or retrieval method.
And once you find a good prompt.
Once you've identified a really effective prompt that meets your needs, the recommendation is to save it properly, maybe in a separate file within your project's code base, making it easier to maintain and reuse reliably. And ideally, set up automated tests to regularly evaluate its performance against some known examples, especially when the underlying model gets updated.
So treat prompt engineering not as a one-off hack, but as an iterative and well-documented engineering discipline. Carefully craft, rigorously test, thoughtfully analyze, document everything, and continuously refine your prompts. And always be prepared to re-experiment with older prompts as the underlying language models evolve and improve. That's a really comprehensive set of best practices to keep in mind.
It is, yeah.
Yeah.
And as we've said a few times, really mastering prompt engineering is an ongoing journey of learning and constant experimentation. It's not something you learn once and you're done.
So, to quickly recap our deep dive today, we've explored the fundamental definition of prompt engineering, what it is, and why it matters. We looked at how to fine-tune LLM output by adjusting settings like output length and the crucial sampling controls, temperature, top K, and top P.
The configurations.
We've also journeyed through a really wide range of powerful prompting techniques, starting from the basics of zero-shot, moving through one-shot and few-shot prompting with examples, understanding the nuances of system, role, and contextual prompts.
Then the more advanced reasoning ones.
Right, the clever step-back technique, the reasoning-focused chain of thought, the reliability-enhancing self-consistency, the branching tree of thoughts, the action-oriented React paradigm.
And APE and code prompting.
Exactly, the automated prompt engineering, APE, and specialized strategies for working with code generating, explaining, translating, debugging. And finally, we've covered a really thorough list of best practices to guide you in crafting more effective prompts day to day.
That's right. And hopefully this discussion, based on the document, has given you a really solid understanding and some practical insights into both the art and the science of prompt engineering.
So, as you're reflecting on everything we've discussed today, think about how you might start applying some of these techniques, maybe starting simple with zero-shot or few-shot to your own information needs and the problems you're trying to solve. And perhaps more broadly, thinking forward, what other incredibly creative and sophisticated applications of prompt-driven AI might be possible in the future? Maybe even beyond the specific methods we've explored in this deep dive today.
That's a great question to ponder. The potential here really does feel vast and honestly is still being discovered every day.